Geometers and seekers of general truths, let us look at a second example here with kites, and not just only to solve this problem, but also to deduce some properties, some additional properties about kites. And you can see there's some information that's given to us here, but it's not a whole lot of information. We know a few things, and I just want to clarify that this length here is 5, this length here is 5, and this length here is 5. And the length that's 12 is this one right here. Okay, this length right here, that's 12. Okay, not the side of the kite. All right, and I've gone ahead and I've marked up this picture over here on the side, and I've also drawn this line in here. And I'm going to reference this picture as well as this picture up here in order for us to gather some information. And if you look at the problem, we're asked to do something with very little information. At least it seems that way. We're given some lengths. They're not even the side lengths of the kite. They're just some arbitrary lengths in the middle here. And we need to figure out all of the interior angles. And so this is going to be quite a bit of a challenge. Okay? So let's look at some of the things we have going on here. If you look at this picture, you can see that you have effectively two isosceles triangles. And we'll just look at triangle SVT here. Because they are isosceles, the base angles of those must be congruent to each other. So those two marks that I made there, they must be congruent to each other. Okay? So we'll write some notes here. Angle SVT is congruent to angle STV by base angles. Okay. And then I'm going to draw the other diagonal in here and see what we can make of it now. So if I draw in this diagonal, you can see that it's the same picture that we had up here. So we can say that this angle up here and this angle over here, they are congruent, okay, by all the work that we did up there. This point in the middle, I guess we'll call it R. And now if you look at these two triangles, the two smaller ones here that we've marked up, you can see that they are in fact congruent to each other by angle side angle. So we can say triangle SVT is congruent to triangle STV by angle side angle. So now we can extend this idea a little bit further, and you know, if you look at this picture here, the original problem that we have, we still don't really know enough. We just know that these two triangles here these two smaller triangles here are congruent to each other, but there's some additional work that we need to show. So one of the things that we can extract, and I'm going to name this here angle 1 and this here angle 2. Okay. Angle 1 and 2 are equal to each other by CPCTC, and they're a linear pair. They add up to 180. The measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Okay. So let's think about this a little bit more. If you have two numbers that add up to 180 and are in fact the same value, okay, so they're congruent and they add up to 180, which means we can deduce from this that, and I'm writing it to the left here, that the measure of angle 1 and the measure of angle 2 are both 90 degrees. So this is a very, very big deal, right? If we know that those angles, in fact, are always 90 degrees, then a lot of our work in this problem here, we can mark this as 90 degrees all the way around. Okay? That if we know that now these two diagonals, SU and VT, intersect at 90-degree angles, then the rest of this problem is totally solvable. Okay, so let's now look at this actual picture. And I'm going to zoom in a little bit here so that we can focus on this picture with the information that we have. All right, so the first thing that I'm going to point out to you here is that if you notice this triangle here, this is triangle ST, I guess we should name something. We should name that middle point something. I think I called it R, right? This yellow triangle here is not only a right triangle, but it's also isosceles. Okay, so this is an isosceles right triangle. So that tells us that these angles here are 45 degrees. And the other triangle on the other side must also be 45 degrees. Okay. So that helps us to figure out some of the angles. And not only that, let me draw out that little triangle here. This length is 5, this length is 5. This is side length S. I have to be careful with my S's and my 5s. So because of the 45-90 theorem, this length out here is 5 root 2. Okay, so this is 5 root 2. And this length here is also 5 root 2. Okay. Then now let us turn our attention to this triangle here, the bigger right triangle down here. We could figure out some information about this. That if this length is 5 and this length is 12, then we can use the Pythagorean Theorem. So we will call this TU. So TU squared is equal to 5 squared plus 12 squared. TU squared, all that comes out to be 169. So TU is equal to the square root of 169, or 13. Okay, so this length here is 13, and this length here is 13. Okay. All right, and it gets better, right? So we can also figure out the measure of this angle here, because one of the things we want to do is figure out the measure of all the angles of this shape. So this angle in here, this is T. I guess we should name this length here. That's T, right? So I'm running out of space, so I'm going to write it over here. I'm going to say that if you look at our picture, I'm going to use the tangent ratio. The tangent of angle T is equal to the opposite side, that's 12 over 5. Okay. Therefore, the tangent inverse of 12 over 5 is going to be equal to the measure of angle T, which is approximately 67.4 degrees. All right, so I think we have ample information now to answer all of that question. That angle there is 67.4. That means this angle over here must also be 67.4. And this angle here is 180 minus 90 minus 67.4, which is 22.6. And this over here is also 22.6. Okay. All right, so a lot of stuff going on here. Let's recap a few things. First, the side lengths. That's what the question asked for, right? The side lengths are 5 root 2, 5 root 2, 13, and 13. The angles, and there are 4 of them for this shape. There is the combination of these two right here, 45, 45. So it happens to be 90 degrees. Then these two here, 45 and 67.4. That's 112.4. And the other one on the other side is the same thing, so 112.4. And then the bottom one here is 22.6 times 2, because those two combine together to make that angle, so that's 45.2 degrees. Okay. So hopefully you can see the logic that comes in through this. We actually started with this picture here, right? This picture is actually key. We were able to show that angle 1 and angle 2 are in fact 90-degree angles. So that's a big deal here, knowing that these two are both 90 degrees here. That allows us to break this problem down into a bunch of right triangle trigonometry problems. Okay, and as always, ask for help if you need it. Make sure you fully understand this problem and all the logic through it. And if you don't, jot down your questions and be prepared to ask them. Thank you for watching and have a wonderful day.